So the next integration technique in 7.4 is going to be integrating when we have to use an algebra technique called completing the square. And to identify this, you're going to be looking at a quotient in your integral. So for example, if you take a look at x squared minus 2x plus 10, so what we have to do, u sub obviously is not going to work, so what we're going to have to do is we're going to have to do what's called completing the square, because we're going to try and rewrite this so that somehow, some way, we can integrate this using one of our inverse trig. So for example, I've got x squared minus 2x. I'm going to group that together, and I'm going to have my plus 10 on the outside of the parentheses. So what I want to do is I want to complete the square on my x's, and if you remember, the way you complete the square on the x's is you're going to take the coefficient of x, which is negative 2, divide it by 2, and then you're going to square it. So negative 2 divided by 2 is negative 1, and negative 1 squared is plus 1. Now, in order to keep this denominator equivalent, since I'm adding 1 here to complete the square, I'm going to have to subtract a 1 so that the denominator is equivalent. So I can rewrite now this integral as 1 over, remember when you complete the square, you now have a perfect square trinomial, which factors into a binomial to the second power. And then negative 1 plus 10 would give me a plus 9 dx. So now in order, this is setting up to possibly be one of my inverse tangents. But remember, this has to be a 1. So what I need to do then is factor a 9 out of this denominator. So when I factor a 9 out, that's going to give me an x minus 1 squared over 9 plus 1 dx. I can pull out my constant of 1/9. And again, remember, I can take now this whole fraction and write it to the second power. So I can write this as x minus 1 over 3 all to the second power plus 1 dx. Because remember, the integral of 1 over x squared plus 1 is my inverse tangent. So now what I can do is I can do a u sub on what's inside my parentheses. So u is equal to x minus 1 over 3. My du is going to be 1/3 dx. So what I end up doing then is I'm going to multiply this integral by a 3. So then when I rewrite my integral in terms of u and du, it's going to be 1/3, because I have to take the 3, I divided out the 1/3, multiply 3 times 1/9, times your integral of 1 over u squared plus 1 du. So again, I know then that this is going to be the integral of 1/3 inverse tangent of u plus c. And then I can plug my x minus 1 over 3 back in. So 1/3 times my inverse tangent of x minus 1 over 3 plus c. So when I take a look at problem number 2, again, this is going to be the square root of 12 minus 4x minus x squared in the denominator. So in order to complete the square, again, I've got this trinomial underneath of this square root. There's a constant in the numerator. In order to complete the square, the coefficient of x squared needs to be a positive 1. So my first step is going to be to rewrite this integral as 1 over the square root. I'm going to factor out a negative 1. That's going to give me an x squared plus 4x. I'm going to leave this blank. That's when I'm going to complete the square. And it's going to be a minus 12. That's all underneath my square root. So, excuse me. So then what I'm going to do is I'm going to complete the square. I'm going to take 4. Actually, this negative 12 needs to go on the inside of the parentheses. Excuse me, I put that in the wrong place. Divide it by 2, and I'm going to square it. So 4 divided by 2 is 2, and then 2 squared is 4. Well, if I add 4 here, I have to subtract 4. So what I have now in my integral is I have 1 over the square root of, there's my negative sign, so there's my negative, x plus 2 to the second power, and this is going to be negative 4 minus 12, which is my minus 16, but it's a negative, so I'm going to make that a plus 16. So now it's looking like it's going to be set up to possibly be my inverse trig. So I'm going to have to, this needs to be a 1, however. So I need to factor out a 16. So I have the integral of 1 over the square root of, I'm going to factor out that 16, and I'm just going to rearrange this order to be 1 minus x plus 2 to the second power all over 16 dx. Now the constant I can pull out is 1 divided by the square root of 16, which is a 1/4, times your integral of 1 over the square root of 1 minus x plus 2 to the second all over 16 dx. Again, I can rewrite this fraction all to the second power. So that's going to be 1/4 times your antiderivative of 1 over the square root of 1 minus x plus 2 all over 4 to the second power dx. So now it's set up to be my inverse sign. So what I can do then is I can let u be equal to x plus 2 over 4. My du is going to be 1/4 dx. So when I had divide a 1/4, I'm going to multiply by 4. So 4 times 1/4 is a 1. So I have the antiderivative of 1 over the square root of 1 minus u squared du, which turns out to be my inverse sign of x plus 2 over 4 plus c. So that's how you can use your completing the square to help you integrate when you've got those x squared and x in the denominator of a fraction. Again, there is no quotient rule, so this is where we can use completing the square as one technique. Now if you look at number 3 is a little different because you do have that variable x in the numerator. Again, we're still going to have, again, a u sub is not going to work because if I did a u equal to x squared minus 4x plus 8, my du would be at 2x minus 4. I've got the x, but I do not have the minus 4. So, but what makes this different is that I have a variable in the numerator. So I'm still going to complete the square on the denominator. So I have x squared minus 4x, and I'm going to pull that plus 8 out. So again, in order to complete the square on my x's, I have to take negative 4, divide it by 2, and square it, which gives me a positive 4. Well, if I add 4 here, I have to subtract 4. So when I rewrite this integral, I have x over, again, I can rewrite this as a binomial to the second power when I factor it, plus 4 dx. Now when you have a case where, again, it's going to look like it could possibly be a u sub or an inverse trig, but this x in the numerator makes it a lot different. So in order to rewrite this so that somehow, some way, I can rewrite this all in terms of u and du, I'm going to let u be equal to what's inside this parentheses of x minus 2. Then x is going to be equal to u plus 2. So now what I can do is rewrite my integral in terms of u plus 2 over u squared plus 4. So now, because I have a sum in the numerator, I'm going to break this larger fraction up into 2 smaller fractions. So I can rewrite this as a u over u squared plus 4 du plus the integral of 2 over u squared plus 4 du. So basically I've undone the addition of these 2 fractions. So now I'm going to integrate each of these fractions. So when I take a look at u divided by u squared plus 4, now I don't want to, it's going to have to be another sub, but I'm not going to use the letter u again because that would be confusing. So I'm just going to choose the letter w. So w is equal to u squared plus 4. My dw will be 2u du. So for this integral right here, I have 1/2, again when I divide that 2 out, times the integral of 1 over u du, which I know is going to be 1/2 times the natural log of u plus c. Again, what is u equal to? U, actually this is w, I'm sorry, 1/2 w times dw. So it's going to be 1/2 times the natural log of w plus c. Remember, w is equal to u squared plus 4. And again, what was u equal to? U was equal to x minus 2 to the second. So for this integral, it's going to be 1/2 times the natural log of the absolute value of x minus 2 squared plus 4. So that's when you have to do a double substitution. But now remember, you're not done. You now have to integrate the second integral. So I'm going to pull out my 2. So I have 2 times the antiderivative of 1 over u squared plus 4 du. Again, this looks like it could be an inverse tangent, but this needs to be a 1. So I need to factor out a 4 out of the denominator. So 1 over 4 times u squared over 4 plus 1 du. So the constant I can pull out is a 1/4. So 2 times 1/4 will give me a 1/2 times your integral of 1 over u over 2 squared plus 1 du. Again, I have to do another sub here. Again, I've used the letter w, I've used the letter u. Let me go ahead and do a v. So v is equal to u over 2. dv is going to be equal to 1/2 du. So I divide out the 1/2. The 2 times 1/2 is going to give me a 1. So I have 1 over v squared plus 1 dv. So then I know that this is going to be my inverse tangent of v plus c. Well, v is equal to u over 2, so my inverse tangent of u over 2, now you got to substitute back in u is equal to x minus 2. So your inverse tangent of x minus 2 over 2. So then my final integral is going to be the inverse tangent of x minus 2 over 2 plus c. And you have to put both pieces together. So that's the final answer there.